Hi students, so good morning. So today our topic is hashing in data structure. So it is one of the searching techniques. So hashing is nothing but searching techniques. Okay. So before going to hashing, we know there are several searching techniques are available. In last class we see about linear search, binary search, bubble sort, search trees, etc. So we have so many searching techniques in data structures, but all of these techniques have unique in time taken, because the time taken for searching a particular element, it always depends on the total number of elements present in my array or my list. So all these techniques are depend on the size of the structure, the size of the array, or the number of elements. Okay. So for example, the linear search take big O of n time to perform the searching operations in the size of n array. The same, the binary search also take big O of long n time to perform the searching operation for n size of array. Here n is the size of the list or array. But when we use the binary search tree, it also takes the same time, big O of long n. It's also depend on the number of elements. So all the techniques are easy, but we struggle in the size of the element, the size of the list, the size of the array. So when the problem became a problematic, means the total number of element became too large. So in this condition, all of these techniques are not good. So when the number of elements become too large, to avoid or overcome this problem, we go to the new concept, hashing. So hashing is one of the searching techniques. It minimizes the number of comparison. So it's different from other techniques in the way of it reduces the number of comparison while performing the searching. So in this slide, we explain the basic searching mechanism, basic hashing mechanism. In hashing mechanism, we using three content. The first one is hash table, hash key value, hash function. So the hash table, using the array concept, used to store the data item. Hash key value are inserted. The hash key values are used to insert our element in the hash table. So based on the key value, we can insert our data item in the hash table. So the hash key value generated by hash function. Hash table, hash key value, the hash function. Everything are interconnected. Now I explain the concept with the use of this diagram. So in hashing, we have three techniques. The first one is hash function. This hash function generates the hash value from the data, from our data. Hash function generates the hash value from our data. Based on this hash value, our data are stored in the hash table. Based on our hash value, our data are stored in the hash table. For example, I give any one key. It performing some hashing function, and finally it return some integer value. So the integer value range from 0 to n. Here n represents the size of the table. If the hash value equal to 4 means my original data stored at 4th place. If my hash value is 0, means my original key value is stored at 0th place. This is the a simple hashing mechanism. So what is hash function? What does it do? So hash function is nothing but it maps the big number or strings or any our input, so converted into small integer value. So why you want to convert the small integer value? Because we have the table size from a particular range. So all the values index are integer from 0, 1, 2, 300, 1000, 10,000. This is the size of my table size. So we must convert our original data into some particular hash value. So the hash function takes the data item as an input and return the small integer value as an output. So the small integer value is known as hash value. So hash value of the data item is used as an index for storing the value in our hash table. So next we see about, so what are the properties we want to maintain in hash function. It minimizes the number of collision. This is a very important properties. When using the hash function, it must reduce the collision occurrence. The second one, the hash value must distribute in uniformly. It distributes the key uniformly over the table, not in the particular range. If my table size is 0 to 100 means my key value ranges from 0 to 100. So not 0 to 50 or 20 to 50, not mid value, not like that. It takes all the values. Okay. Now we go to C1, a simple example based on separate chaining. So the separate chaining is one of the techniques used in hash function. So using the hash function, the problems are using the hash function. Here the functions are given. So what is the function? Key mode by 7. This is my simple hash function. Insert the following 7 elements. So our elements are 7. We must insert the 7 element into the hash table by using the function key mode 7. Listen. So now we go to solution. Our first element is 50. Okay, our first element is 50. So what is my table size? We know our element, we know our the hash function. So what is the table size? So the table size is 7. The range is table size 7. Why? Because I take 7. In the sum they give key mode by 7. So I take this table size as 7. So the ranges start from 0 to 7. The hash values ranges from 0 to 7 because the hash value always depend the size of table. So here I create a simple table with a size of 7, ranges 0 to 7. This is a step 1. You create a table in the name of hash table. Then second, here I choose 50. This is the first element in the sum. So my key value is 50. The key value mod by 7. So I got the remaining value 1. The remaining value is 1. This is my output. So the 1 is my hash value. The 1 is my hash value. So I get 1 for the data 50. So I store my data 50 in the table at first position. Okay. My element is 50. My key value is 50. For 50, I apply the hash function mod by 7. So after getting hash value 1 from this hash function, I store the data 50 at first place. The second is my key value is 700. The key value is 700. We apply the hash function 700 mod by 7. The output is 0. So the 0th is the place for 700. So I put or insert the 700 at 0th place. My third element is 76. Again we apply the same hash function for the key 76. 76 mod by 7. The output of this function is 6. So hash value is 6. At the 6th position I insert my element 76. Next, my next element is 85. So I apply the mod function 85 mod by 7. The output is 1. But 1 is already exist. So we have the 50 at the place of 1. Again my hash value is 1. What happened? The 1 is already occupied, so the collision occurs. This is known as a collision. the 1 is not free, it is occupied by 50, but 85 also same hash value. So this is the concept of collision. So in this step or in this problem, I create a new node for the 85. Okay, these new nodes are connected with the first place. It like linked list concept. Okay, the node 50 is connected with the node 85. Okay, this is the concept of linked list. To avoid the collision, we can use this technique. Then my next element is 92. The 92 mod by 7, the output is 1. So 1 is here key value, hash value. Okay, see the diagram. The 1 is already occupied by 50, then followed by 85. So again the 92 also have a same key value 1. So what happened? The collision occur. So I want to create a new node. After creating a new node for 92, I want to join with the last node in the linked list. Okay, so see this example. So already 50 and 85 share the first place by using the concept of linked list. Okay, again the one more node 92 is created and joined with 85. So that means the node 50, node 85, node 92, so make a chain concept, separate chain concept. Then only it is known as a separate chaining method. The last element is 73. The 73 mod by 7, this is our hash function. The hash function return 3 as the output. So in my table, the third place is free. There is no element, so no collision occur. So I directly insert the 73 at the third position. So all of the elements are inserted in our table. 700 at first position, 50 at my first position, 85 in the same position, 92 at also same position without the collision. Okay, so 73 at the third position, 76 at the sixth position. From this diagram, you can check there are some relationship between the key value and my key element. So 700 zeroth value is present in zeroth position, 73 at the third position, 76 at the sixth position. So if you want check any number based on odd or even, divide by 2, divide by 10, like that, you can particularly check the particular row only, not check from top to bottom. You check randomly with the property and satisfy the condition for your element. Okay, so this is the simple concept of hash table. So finally our data are saved in the concept. Sorry, the one more element is 101. The 101 how also take the key value 3 from the hash function. So same as what happened, the collision again occur. So we modify the table as like showing in the figure. The 73, I create one more node or one more cell for 101. It connect with the 73. This is the final hash table with the values.